This problem, we are required to find the value of I naught, and it is different from the previous problems because in this problem we are introducing a dependent voltage source. Another video. Before we proceed to solving the problem, don't forget to hit the like button and subscribe, and hit the notification bell. Using mesh analysis, the first thing we want to do is that we want to identify our meshes. In this problem, we have three meshes. We have mesh 1, mesh 2, and mesh 3. So then the next thing we do is we assign currents to each mesh. So let's call this I1, and then this would be I2, and then this would be I3. Okay, then the next thing we want to do is that we want to write the KVL equations in each mesh. Now recall, with the end goal in mind, that we are looking for I naught, okay, and it's the current flowing in this direction. So the value of I naught would be I1 with I2 opposing it. So the value of I naught would be I1 minus I2. So this is what we are trying to calculate. So in order to calculate that, we'll be writing the equation for each mesh, KVL equations for each mesh. So in mesh 1, we're starting from here, and we have 10 I1 into I1, then I2 is opposing it, minus I2, then plus 12 into I1 with I3 opposing it, minus I3, then minus 24, all equal 0. Then we can expand this further, and we would have 22 I1, okay, minus 10 I2 minus 12 I3 equals 24, and we can call this our first equation. We can then proceed to mesh 2 and write the KVL equation there. Mesh 2. So in mesh 2, I'm going to move in this direction now. I'm going to say 24 I2, 24 I2, then 4 I2, then we have the current I3 flowing through its opposing current I2, so that would be plus 4 into I2 minus I3, okay. Then we come here, then we have 10 into I2 minus I1, so plus 10 into I2 minus I1. Then we equate everything to 0, that is KVL. Then we can then expand this, so that would be 24 plus 4 plus 10, that would be 38. So we have 38 I2, okay, minus 4 I3 minus 10 I1, all equal 0, and we can call this our second equation, okay. Then we can proceed to mesh 3 and write the KVL equation there. So mesh 3, KVL equation in mesh 3. So we start from here, okay, and we move like this. So that will be, we have 4 into I3 minus okay, I2 is opposing I3 there, okay. Then we use positive sign here, so that we plus 4 I naught, okay. Then we eat this one. Then without the current flowing through to be I3 minus I1 plus 12 into I3 minus I1. Then we equate it all to 0. Now, recall that this is I naught. So I naught is flowing in this direction. So that would be I1, then opposed by I2. So I naught is equals to I1. I naught equals I1 minus I2. We already stated that earlier. So we can substitute that here, and we would have 4 into I3 minus I2 plus 4 into I1 minus I2 plus 12 into I3 minus I1 all equals 0. Okay, then we can expand this, and we would have 4I3 minus 4I2 plus 4I1 minus 4I2, okay, and plus 12I3 minus 12I1. Then we equate it all to 0. Okay, then we can simplify this further, and we would have 16I3, and we would have 4 okay, that would be 8 minus 8I2. Then we have 4 minus 12, so that would be minus 8I1. We equate it all to 0, and we can call this our third equation. We can then proceed to solving these equations simultaneously, and that will give us the values of I1, I2, and I3. And with that, we arrive at the value of I1 to be 2.25 amperes, and I2 would be equals to 0.75 amperes, and I3 would be equals to 1.5 amperes. Now we can then proceed to find the value of I naught, which is the original question that we were asked. Then I naught would be I1 minus I2, and that would be equals to 1.5 amperes. Video, don't forget to hit the like button and subscribe. See you in the next video. Bye.